they took a group of people and they actually started doing brain scans of these people before they put them on these medications. And when I talk about these medications, I guess we haven't really got to the point. Yeah. These medications we're talking about are GLP-1 receptor agonists like Ozempic. That's the one that seems to resonate with everybody. They've heard of Ozempic and they just know people lose a lot of weight when they take it, right? GLP-1s are one of these nutrient stimulated hormones that we talked about, and perhaps the most prominent, and also the ones that are most susceptible to being destroyed by that DPP-4 that we talked about. So when we talk about metabolic dysfunction, obesity, diabetes, oftentimes people are dysregulated in that hormone. They're either their bodies are not getting it to last long enough to signal to the brain that they're full, et cetera. And so what they found is, it's interesting how they kind of discovered GLP-1 receptor agonists, but they found a way to make peptides and put them in like this fatty molecule that makes it so that DPP-4 can't destroy them. And so it just makes it last longer in your body. So it binds to the receptors in your body the same way that the natural stuff that you make does, but it can't be killed by that gut bacteria byproduct DPP-4.
Okay, so DPP-4 is the thing that ruins the hormones. Where does that come from again?
It's a byproduct of gut bacteria. So that gut, and this again, studies have been done to show that in people with type 2 diabetes, especially, those gut bacteria that produce DPP-4 are orders of magnitude higher in the guts of people who are diabetic than people who are not. So in other words, you have an exorbitantly high amount of DPP-4 that's destroying what's the word for it? Scientific word is endogenous, but it's just a fancy way of saying the kind your body makes. And that DPP-4 destroys it. So you're not getting the same kind of signaling between your gut and your brain. There's this gut-brain axis.
Say to stop eating.
To say stop eating. But even, it's responsible for other things. Besides just satiation, it's responsible for, signaling the beta cells in your pancreas to release insulin efficiently. It's designed to act in your brain to actually slow how quickly your stomach and digestive system processes food. So it slows digestion, signals fullness, signals the beta cells in the pancreas to make insulin. All these things are affecting, multiple metabolic processes beyond just making you eat less. But that's certainly the biggest part that helps to lead to weight loss ultimately. But we're talking about DPP-4 and how these GLP-1 receptor agonists have been designed to not be ruined by the DPP-4, right? And so they found a way to just basically make a peptide that mimics the hormone that your body makes, but it can't be destroyed by the DPP-4. And then it binds to the receptors. So you're getting that signaling sort of restored between your gut and your brain to signal fullness and satiation. And so in the study that we're talking about, they start people who are obese by looking at pictures of highly palatable foods, right? So they're looking at cheeseburgers and they're looking at, pies and cakes and ice cream and all that stuff. And they're watching on brain scans, these areas of the brain light up. Okay. So they can physically see them light up. And then they're introduced to tirzepatide and an older version called liraglutide. The folks on tirzepatide, which is the newest iteration of these drugs, it's called Mounjaro and Zepbound are the marketing names for them on the market. Mounjaro is what I take. My handle is man on the Mounjaro. That's for diabetes. The Zepbound is the same exact thing, just the FDA indication is for obesity, right? But it's all tirzepatide. The folks that were given tirzepatide, this newer drug, they watched those areas on the brain as they were given the drug just stop lighting up, right? So when the brain once responded in a certain way to highly palatable foods or being presented with highly palatable foods, it is as if the tirzepatide just sort of shut down those parts of the brain that were inclined to be excitable towards them. And so this was one of the newer studies that just came out that maybe shows a little bit of like that food noise happening in the brain, that that excitability, that consuming thoughts, all those things. And these medications, they work in the brain to sort of quiet that all down.